Hello everyone. In the last lecture video about the synchronous generator, we have discussed about the working principle of the synchronous generator and what are the types of rotor. Let us revise the thing what we have discussed in the previous lecture video. So in the synchronous generator also called as a alternator. What do you mean by synchronous generator? Synchronous generator, it is a three-phase AC generator. So already we have discussed what is generator, what is motor. So generally what is generator? Generator which converts mechanical energy into electrical energy. Motor which converts electrical energy into mechanical energy. So in the DC generator, whatever the concept mechanical energy we are supplying at the input which converts into DC signal because of the commutator part. But internally the alternating voltage generated, after that commutator converts the alternating voltage into direct voltage. But in the synchronous generator which generates three-phase AC signal, that's why it is called it as a alternator. So, in the synchronous generator, this is the construction part. So, in the DC generator, armature with the conductors are rotating with the stationary magnetic field. That construction you have studied, we have discussed about that. But in the alternator or synchronous generator, magnets are rotating part and armature with the conductors are stationary part, because there are many advantages, because this three-phase AC generator, it generates in the voltage in the form in the kilovolt range, 11 kV to 20 kV voltage generated in the alternator or synchronous generator too. So because of the high voltage, there should be an insulator or insulating part should be there. So if it is a conductor placed in a stator part, it is easily the insulation can be provided to the conductor, so that the alternator, the collection of the three-phase AC signal from the stationary part is easy compared to from the rotating part. So armature conductors are placed in as a stationary part and magnets are rotating. And also the magnets consist of field windings or something. It has some conductors placed on the magnets, so that when the external DC supply provided to that magnet field winding, what will happen? It will excite the magnets. So because of current flows through the field winding which generates the magnetic field, so that the whole part will become an electromagnet. Because why the electromagnets are required? We want something desired magnetic field. Permanent magnet cannot give such a desired magnetic field. So we want something electromagnet. How to make electromagnet? Because the current, whenever the current flowing through some magnetic material which becomes electromagnet, which generates some magnetic field. So that electromagnetic, you can see in this diagram. So the magnetic field generated by the magnets is done by something field winding is wound on the magnets, and that excitation current is supplied by the external source, that is called as excitation source. Because of this excitation source, excitation current flows, and that will make that magnetic material into electromagnet. Whenever these magnets are rotating, which will cut the magnetic field lines with a, or this magnetic field sweeps the conductor placed on the stationary part. So whichever the conductor experiences the north pole, that generates the EMF in one direction. Whichever the conductor experience the south pole magnetic field, which generates the magnetic field in EMF in the other direction. So alternating EMF generated, but here we need to remember there is no one set of conductors in the armature, because it is a three-phase AC generator. There are three set of windings. You can see in this diagram A, B, C. Or in the theory, in the three-phase AC circuit, we have represented as RYB, red, yellow, blue color. Here, same thing A, B, C. It is a different set of windings. Three set of windings are placed in such a way that the EMF generated in these conductors are 120-degree phase difference with each other. So, three stator windings 120-degree apart, and because this is a stationary part, whenever the magnets are rotating, which sweeps the magnetic field through the conductor. So, in the conductors, there is a generation of the EMF. So, there is a changes in the generation. So, whichever the conductor experience a north pole magnetic field, that generates a positive EMF, positive cycle of the EMF. Whichever the conductor experience a north pole magnetic field, which generates the EMF in the negative direction. But three set of windings are 120-degree apart. Magnet EMF generated across the conductors also 120-degree phase difference with each other. You can observe red, yellow, blue. So red, if you compare with the red, yellow is 120-degree lagging. If you compare the blue along with the yellow, it is 120-degree lagging. With respect to red, it is 240-degree lagging. Already we have discussed all these terms in three-phase AC circuit. Same concept is applied here, but synchronous generator is a three-phase AC generator. What are the advantages? One more is non-salient. Here there is no projecting part from the structure. North and south poles are placed in a cylindrical structure along with the field winding. So there is no any projecting part. What are the difference between these two? Silent pole type rotor, it is a large diameter. So it has large diameter and small axial length. So what is how many poles can be placed? Because of the large in diameter, around 30 to 36 poles can be placed on a silent pole type rotor. But in the cylindrical rotor or non-silent pole type rotor, it has a very small diameter and large axial length. Because of the small diameter, only 1 to 2 poles, 2 to 4 poles can be placed over the cylindrical rotor type. But other differences, silent pole type non-uniform air gap, but in the cylindrical it has uniform air gap between the armature structure and rotor part. And the structure vertical axis type, here horizontal axis type. And one more important feature, silent pole type rotor suitable for low speed hydro generator. It is suitable for low speed hydro generator. Cylindrical rotor is suitable for high speed turbo alternator or turbo generator. And it needs damper winding to avoid the loss in the windings. It needs damper winding. It does not require a damper winding, and windage loss is higher, windage loss is lower. And one more difference, because mechanical energy should be supplied to the alternator from prime mover. So here usually silent pole type rotor hydraulic turbines. Hydro turbines are used as a prime mover, but in the cylindrical, because of the high speed, the prime movers are used as a steam turbines. Steam turbines provide the mechanical energy so that will give the mechanical energy to the alternator and it generates very high speed or very the EMF is very high and suitable for high speed turbo alternator. These are the main difference between salient pole type rotor, cylindrical type rotor or non-salient pole type rotor. It's a very important question asked in the old question paper. What are the difference between salient pole type rotor and cylindrical pole type rotor? You need to draw the diagram. Along with the diagram, you need to explain what are the differences, what are the difference between the salient and non-salient type rotor. And the frequency. What is the frequency of the generated EMF? So here the frequency, it's a one cycle is generated in an armature coil when a pair of field poles passes over the coil. So number of cycles generated by one revolution of the rotor is equal to P by 2 because always the number of cycles, for example, if there are two poles then only one cycle is generated. If there are four poles present in the rotor, then for a one complete revolution, it generates two cycles of EMF. So, number of cycles generated by one revolution of the rotor is equal to P by 2. P is the number of poles on the rotor in the alternator. That we need to remember. So, frequency. What is the frequency of the generated EMF? It can be calculated by, it is a number of cycles per second. Correct? Frequency, what is the definition of the frequency? Number of cycles per second. How can you write in terms of revolution and cycles? So, frequency can be written as number of cycles per revolution into revolutions per second. So, number of cycles per revolution, already we have mentioned P by 2. For one complete 360-degree rotation, one revolution, the number of cycles are P by 2, number of poles divided by 2. So, P by 2 is the number of cycles per revolution into revolution per second N by 60 because N is the RPM, revolution per minute. Divide by 60, you will get revolution per second. So, frequency is Pn by 120. This is the formula to calculate what is the frequency of the generated EMF. It is a poles, number of poles into revolution per minute divided by 120. Pn by 120 is the frequency of the generated EMF. How can you write the synchronous speed? So, a machine which runs at synchronous speed is called synchronous machine. That's why synchronous speed is the speed of the revolution of the magnetic field in the stator winding of the motor. It is the speed at which electromotive force is produced by the alternating machine. Thus, an AC machine in which rotor moved at a speed and built a constant relationship between the frequency of the voltage in the armature winding and the number of poles is called a synchronous machine. So, synchronous generator which runs at a synchronous speed. How to write synchronous speed? Ns is equal to 120 F by P. Already we have written frequency is Pn by 120. What is N? N is 120 F by P. This is the speed, synchronous speed of the alternator. So, the speed at which synchronous generator runs is called it as a synchronous speed. Ns is equal to 120 F by P. And also armature conductor, how these armature conductors are placed. It's a very important factor. One is pitch factor and distribution factor. So, this is the main parameter used to define how much EMF generated across the conductors. How the conductors are placed on the armature slots. Because like these factor actually which affects the EMF equation of the alternator or synchronous generator. So what is that? Pitch factor and what is distribution factor? So to explain what is pitch factor and distribution factor, let us discuss what is pole pitch. Pole pitch. So, the pole pitch is defined as peripheral distance between center of two adjacent poles in DC machine. This distance is measured in terms of armature slots or armature conductor come between two adjacent pole centers. Normally, the pole pitch is expressed in terms of number of slots per pole, denoted as N. So, how many number of slots per pole, that is useful for calculating the pole pitch or pitch factor. You can see here, pole pitch means number of slots. For example, there are 9 slots under single pole. Then you can see what is, if you connect the conductor from the first slots to the 9th slot, then it will make 180-degree electrical angle, or the EMF generated between those two conductors is 180-degree electrical. The degree of the electrical is 180-degree phase difference between each other. So 180-degree is the one pole pitch, or number of slots comes under the single pole. If you connect the conductor from the first slot to the last slot under the single pole, then it will make the 180-degree phase difference in the EMF. That is called as a pole pitch. Coil span is 180-degree. Okay. So this will defines the pole pitch. So n number of slots per pole. So you can see in this diagram. So what is the under one coil? Because if you consider the north and south pole, how many number of between the how many number of slots are present between the two poles? You can see in this diagram, because the armature structure has many slots. So in the slots many conductors are placed. So and between north and south pole, if you have, there are 5 slots, then if you connect the coil, one coil from the first slot to the last slot, then the 180-degree phase EMF generated between the two conductors is 180-degree electrical degree. So that is called as a what is a pole pitch. Okay, so coil side 1 is connected to the coil side 2 between the two poles, north and south pole, then there is a 180-degree electrical angle between the EMF. Okay, and between these two. Silent pole type rotor, it is a large diameter. So it has large diameter and small axial length. So what is how many poles can be placed? Because of the large in diameter, around 30 to 36 poles can be placed on a silent pole type rotor. But in the cylindrical rotor or non-silent pole type rotor, it has a very small diameter and large axial length. Because of the small diameter, only 1 to 2 poles, 2 to 4 poles can be placed over the cylindrical rotor type. But other differences, silent pole type non-uniform air gap, but in the cylindrical it has uniform air gap between the armature structure and rotor part. And the structure vertical axis type, here horizontal axis type. And one more important feature, silent pole type rotor suitable for low speed hydro generator. It is suitable for low speed hydro generator. Cylindrical rotor is suitable for high speed turbo alternator or turbo generator. And it needs damper winding to avoid the loss in the windings. It needs damper winding. It does not require a damper winding, and windage loss is higher, windage loss is lower. And one more difference, because mechanical energy should be supplied to the alternator from prime mover. So here usually silent pole type rotor, hydraulic turbines. Hydro turbines are used as a prime mover, but in the cylindrical, because of the high speed, the prime movers are used as a steam turbines. Steam turbines provide the mechanical energy so that that will give the mechanical energy to the alternator, and it generates very high speed or very the EMF is very high and suitable for high speed turbo alternator. These are the main difference between salient pole type rotor, cylindrical type rotor or non-salient pole type rotor. It's a very important question asked in the old question paper. What are the difference between salient pole type rotor and cylindrical pole type rotor? You need to draw the diagram. Along with the diagram, you need to explain what are the differences, what are the difference between the pitch coil and short pitch coil. So pitch factor or coil span factor is defined as the ratio of EMF generated in short pitch coil to the EMF generated in the full pitch coil. Okay, and it is always less than unity. Kp is always less than unity practically, because it is not connected full pitch. Always it is connected in a manner, it is less than 180 degree, it is always a short pitch. So Kp is always less than 180. So this factor basically represents the effect of short pitch winding on generated EMF across the winding terminals of electrical machine. This is a pitch factor. So Kp is the resultant EMF of short pitch coil to the resultant EMF of full pitch coil. What do you mean by full pitch coil? If there are 10 slots under single pole, and if you connect the conductor from the first slot to the last 10th slot, then such connection is full pitch coil. There is a 180 degree electrical phase difference between the two conductor. If the connection is from the first slot to the 9th slot or first to 8th slot, it is a angle between the two conductor is less than 180 degree, then such connection is called it as a short pitch coil. So how to connect? So it is also calculated in terms of phasor sum of coil side EMF divided by arithmetic sum of coil side EMF. From this diagram, Kp is phasor sum. It is 2e cos alpha by 2 divided by arithmetic sum 2e, e and e, 2e. If you add 2 EMF, e, it will be arithmetic sum is 2e, but phasor sum is 2e cos alpha by 2. So it will be calculated by cos alpha by 2. So alpha is the slot angle, or how much it is short pitched angle, that is alpha. So Kp is calculated by cos alpha by 2. So what do you mean by Kp? It is a pitch factor or coil span factor. It is a ratio of EMF generated in the short pitch coil to the EMF generated in the full pitch coil. And one more parameter, it's a distribution factor. What do you mean by distribution factor? It is a ratio of EMF generated in the distributed winding to the EMF. You can see distribution factor is calculated by sine of m beta by 2 divided by m beta by 2. So this will be like, it is a sine m beta by 2 divided by m sine beta by 2, where m is the number of slots per pole per phase. So it is calculated by Kd, distribution factor is equal to sine m beta by 2 divided by m sine beta by 2. What is beta? Beta is the slot angle. So this is the 4-pole 3-phase alternator, where how to calculate Kp cos beta by 2, coil span factor or pitch factor. So what is beta? What is the short pitch angle? So how to calculate? So there are 4 poles. 4 poles in a 3-phase alternator has 36 slots. So how to calculate small n? Small n is the number of slots per pole. So total number of slots is 36 divided by how many numbers of pole? 4. So you will be getting number of slots per pole is 9. So it has how much? What is the slot angle? What is the angle for a single slot? So if it is a full pitch coil, if you connect the total 9 slots, if it is a first slot to the 9th slot, if you connect the conductor, it is a full pitch coil. Then what is the angle? 180 degree. So 180 degree divided by n, you will be getting 20 degree. Alpha is 20. What do you mean by alpha? It is a slot angle. So for a one slot which gives the phase difference of 20 degree. So how, if it is a short pitch by one slot, then the angle of short pitch is 1 into alpha 20 degree. So how to calculate Kp? Cos beta by 2, cos of 20 divided by 2. It's 0.9848. This is the formula to calculate what is a coil span factor or vector. How to calculate the E.M.F equation of an alternator? E.M.F equation of an alternator is very important derivation. Here you need to remember few parameter: phi flux per pole, P number of poles, N synchronous speed, F frequency of the induced E.M.F, Z is the total number of conductors, ZPH conductors per phase connected in series. So it will be calculated by total number of conductor divided by 3. So because it is a 3-phase AC generator, how much conductors comes under the single phase? It is Z total divided by 3. Okay. So how to calculate E.M.F equation? So consider a single conductor placed in a slot. So average value of E.M.F induced in a single conductor is d phi by dt according to Faraday's law. For one revolution of a conductor, what is the average E.M.F per conductor? Flux cut in one revolution into time taken for one revolution. So, what is the flux cut in one revolution? Flux cut in one revolution is phi. But what is a cut in one revolution? Phi into P. Phi is the flux per pole. How many number of poles? That is P. If you multiply P into phi, the flux cut in one revolution you will be getting. What is the time taken for one revolution? It is 60 by N. 60 because N is the RPM. What is the time taken for a one revolution? It's 60 divided by N. So you will be getting E is equal to QP by 60 by N or phi PNS divided by 60. But the frequency is Pn by 120. Already we have discussed. If you substitute here P, it will be like it is Pn by 60 into 2F. And one more parameter, it's a distribution factor. What do you mean by distribution factor? It is a ratio of E.M.F generated in the distributed winding to the E.M.F generated in the concentrated winding. What do you mean by concentrated winding? If all the coils out of any one phase under one pole are bunched in one slot, then winding is known as concentrated winding. And the total E.M.F induced is equal to the arithmetic sum of the E.M.F induced in all. Remember one thing, always it will be RMS value of the E.M.F induced is also represented in the turn, number of turns per phase. So one turn will be, it will generate the one turn with the using of the two conductor. Two conductors makes one turn. So TPH is equal to ZPH divided by 2. So we will be getting the RMS value of the E.M.F is equal to 4.44 F5 TPH. But one thing we need to remember, real like ideal case Kp and Kd is equal to 1 because we have considered full pitch coil and concentrated winding. But practically coils are short pitched and windings are distributed. So RMS value of the induced EMF is reduced by the pitch factor Kp and distribution factor Kd. So that EPH RMS value of the EMF per phase is equal to 4.44 F5 TPH Kp into Kd. This is the final equation of the alternator. So by using that equation, we have to solve one problem. 3-phase 50 Hz 16 pole alternator with star connected winding has 144 slots with 10 conductors per slot. The flux per pole is 24.8 milliweber and it's sinusoidally distributed. The coils are full pitch. Already they have given coils are full pitch. So Kp is equal to 1. But calculate the speed, line EMF, assume winding factor Kd is equal to 0.96. So they have given the Kd value 0.96. But coils are full pitch. Kp should be considered as 1. How to calculate? This is the equation. EPH, the RMS value of the EMF per phase is equal to 4.44 F5 TPH Kp Kd. How to calculate TPH? TPH is equal to ZPH divided by 2. What is ZPH? It is total number of conductor divided by 3 divided by 2. How many total number of conductor? Because there are 144 slots. Each slot has 10 conductors. So 1440 is the total number of conductor. Divided by 3 you will be getting ZPH. Divided by 2 you will be getting TPH. So TPH number of turns per phase is 240. How to calculate speed? It is 120 F by P. So it is 375 RPM. And assuming full pitch coil, Kp is equal to 1, Kd is 0.96. If you substitute in this equation 4.44 F 5 TPH Kp Kd, you'll be getting 1268.5 volt. So what is the line voltage? Line voltage in the star connected already we have discussed. EL is equal to root 3 into EPH. If you multiply root 3 into 1268.5, you'll be getting 2197 volt is the line voltage. This is the, so I have already shared the problems from the synchronous generator in Google Classroom. Go through it. If you have any doubt, please ask me. And if go through this video about the synchronous generator, if you have any queries, please approach me. I will help you. So thank you. Study for the second internal till synchronous generator, starting from the module 3, transformer, domestic wiring, module 4, DC generator, DC motor, and module 5, only first chapter, synchronous generator. So study for the second internal. Thank you.